So this is our last example under the application of the equation of linear motion. It's saying that a taxi being driven at a steady speed of 25 meters per second bypasses a stationary police car. 2 seconds later, the police car started off at rest, accelerating at a rate of 6 meters per second in pursuit of the taxi or following the taxi. Now the question is find when and where the two cars were together. So when we're talking about when, we are looking at the time and where the distance covered. So if we are to solve this, then we can say for the taxi, if I consider them using this equation here, using S equaling to ut plus a half at squared. And then for the taxi, if I'm to look at the taxi, I will say what is the distance covered by the taxi from the time it bypassed the police. So the police was at rest, standing, okay? And then this taxi was being driven at a steady speed. It bypassed the police car. After bypassing the police car, 2 seconds later, the police car decided now to start chasing that or following up the taxi. Now the question is where did it find it and after what time? So now we're saying that if we're using this equation and considering the taxi, what is the distance covered by the taxi from the time it bypassed the police and up to time where it was caught? So we shall say the distance is SC, maybe 1 should be equaling to, I can say ST for the taxi, and then should be equaling to U. It is being driven at a constant speed of, steady speed of 25 times the time. Is that okay? Plus a half times acceleration. Because it is being driven at a steady speed, acceleration will be 0. Is that okay? And then that means that the distance covered by the taxi will be equaling to 25t. I can call this equation 1. And then if I come to for the police car, if I'm looking at the police car, using the same equation, I would also say that the police car, distance covered by the police car, SP, distance of the police car, will be equaling to U. But because we said that the police car started from rest, that means that its initial speed is 0. Okay? So you can say it is 0 plus. All this component will die to 0. Ut times any times 0 times anything now will be 0. Plus a half acceleration. It accelerated at a rate of 6. And then times time. Okay? Remember, the taxi first bypassed. And then after 2 seconds, that is when now the police car started now following the taxi. What does that mean? That means that there is a time lag of 2 seconds. If the taxi is using time t, and then it means that the police car should use t minus 2. Okay? Because it is delayed by 2 seconds. Therefore, I will say here it is t minus 2. Where 2 is the time lag that it started 2 seconds later. So its time will be smaller, but now squared. So we can now simplify this and say this is SP equaling to, that is 3. You can decide to open bracket here and say it is t squared minus that times that minus 40 and then plus 4. And then your SP, which is the distance of the police car, will be equaling to 3t squared. If you open that and then open that also minus 12t plus what? And then plus 12 as well. And then I'll call this one equation 2. Is that okay? And then let's look at what is very true from the time when the taxi bypassed the stationary car. What is very true is that by the time that the police car is stopping, the taxi stop, they are now together. The distance covered will be the same because they all started from the same point. Is that okay? They all started from the same point. The timing of the taxi started when it was just bypassing the police car. Therefore, at the time when the two are together, distance covered is the same. When the two cars are together, comma, the distance covered is the same. That is to say, ST equal to SB. That is what we are meaning there. The distance will be the same. Therefore, I have the right for saying that 25t is equal to 3t squared minus 12t plus 12. I can rearrange this quadratic equation here by bringing everything this side. I'll have 3t squared. Bring that on that side, it will be minus 37. Minus 37. Okay? Bring this side to subtract on this. Minus 25 minus 12. That's minus 37t. And then plus the 12 will give us 0. So, we have here, if we are to use quadratic equation, that t equal to negative b plus or minus root of b squared minus 4ac all over 2a. What is my a? My a is 3. What is my b? If you're comparing, my b will be negative 37. And then what is my c? My c will be equaling to 12. So that means that my t will be equal to negative b. But what is b? B is negative 37. And then plus or minus root of b squared. That is negative 37 squared. And then minus 4 times the a. My a we said is 3 times the c12 out of 2a, which is 2 times 3. And then from there you can press get t1 and get t2. Please, when you're solving quadratic, be confident with your expectation that the roots can be real, imaginary, or if it is real, it can be repeated or distinct. So when you're solving this, be in position of making conclusion. Should we get the answer as imaginary? Should the values of t be imaginary? The implication is that the police car will never get the taxi. But if you get the real root, a real value, and then it means that the police car will be in position of catching up with the taxi. So let's now press that. Pick your calculator and then solve that. Degree 2. And then I can say that is 3. And then negative 37. And then I have here 12. And then I have this as 12. And then this one has 0.333, okay, second. Is that okay? And now the question is, among the two answers we have got, which one is very right? All of them are positive. There is nothing like negative in that you say time cannot be negative. All of them are positive. Which answer should we go with? So, let's see which answer we should choose. Don't forget, we said that for the police car, the time is supposed to be t minus 2 to get the time for police. But for the taxi, it is just t. Now, look at a scenario where you are assuming t is this value here. And now you are using this t to get the time for the police car, which is supposed to be t minus 2. That will imply that you are supposed now to say this t, which is 0.33 minus 2. It will throw you into negatives. And what is the implication of negative? That means that the time is negative. It even happened before. So that means that this t here cannot be used. Why? Because if we are using it, it makes the time for the police car to be a negative value. Because we said if this one is taking t, this one should take t minus 2. Therefore, if t is this value, it makes this one to go in negative. Therefore, the answer should be 12. The time taken by the taxi is 12. And for the time for the police car, I can also here, therefore, time for the taxi is 12 seconds, and for the what? For the police is 12 minus, because it's t minus 2, which is equivalent to 10 seconds. That one works for the time taken for the two to be together, because the time will be different. One went first and then another one followed afterwards. Therefore, the time will be different, but the distance covered will be the same. So now, if we are to calculate the distance, we can now substitute in any of the equation, because even if you substitute here or you substitute here, you will get the same answer. So if I'm substituting in equation 1, substituting for t in equation 1, I will say S equal to 25 times my t, isn't it? This t here times 12. S equaling to, you can pick your calculator there, and then you say, you can now say it is 25 times 12 to give you 300. So that means that the distance covered is 300. And this distance is the same for all of them. Even if you bring it here, you take it where, you will get the same value. But if you're using for this, you should use now this time of 10. Therefore, we can now conclude that the distance covered is 300 meters. So that will be our final answer. Thank you.